Alrighties, hi everyone, welcome to your pre-lesson video today on polygons. Alright, so let's get right into it because we have a lot of your foundational information that we are going to get into today. Alright, so first things first is, what is a triangle, right? So obviously we know that a triangle is a shape that has three sides because of the word tri, right? Now, the total interior angle of a triangle is going to be 180 degrees, so ingrain that into your mind because that is really, really important to know. All right. Now, the thing about a triangle is that this key information, right? So sum of two side lengths is greater than the third side length. So let's take this. Let's take 5 plus 7, right? We will get 12. So we know that these two is going to be greater than the third side, 6. Same thing, we go the other way. We do 5 plus 6, which is 11. It's greater than 7, which is the third side length. So that's how we test if it's a triangle or not. If we add the two side lengths together, their total should be greater than the third side length. And we'll actually see this in some of the practice questions that we have in our deep dive lesson. All right? Now, there are many types of triangles, and now these three, scalene, isosceles, and equilateral triangle, are based on how their side lengths. All right, so let's look. So a scalene triangle is a triangle where all three sides have different lengths and all angles are different measures. As you can see, none of them match up. So look at these lines are not the same. It's a 1 thick, 2 thick, and 3 thick, which means that all three sides have different lengths. Same thing with their angles, 1, 2, 3. So that means they're all different measures, all right? So just remember, scalene, all different. Now, and then an isosceles triangle is a triangle where two of its sides are of equal length and angle. So as you can see, these two sides are marked with 1 thick, which means these two sides have the same length. Same with these angles, right? They have this one symbol, like with just one curve, which means that these two angles are going to be the same. And that's really, really important to know, especially for next week when we get into congruent triangles. We're going to solve a lot of questions based on isosceles triangles, okay? Now, an equilateral triangle, as you can see, it's a triangle where all three sides are of equal length and each angle is going to be 60 degrees. This is already predetermined. But yes, so this would be an equilateral triangle. See how all three angles are marked by just one line, which means they're all equal and they're all definitely 60 degrees. It's already known. Same with the sides, only 1 thick, which means that all the sides are of equal length. All right. Now, we can also differentiate triangles by their angle. All right, so as you can see, a right triangle is a triangle where one angle is 90 degrees. So if we look here, right, this part here would be 90 degrees, and that's why we would call these two a right triangle. Now, as you can see, we have a right scalene triangle where none of the sides, are equal because it's a scalene triangle. And then we could also have a right isosceles triangle because two of the sides are equal, just like this. All right. And actually, we'll see next week when we get into right triangles, we're going to see on the properties of a 30, 60, 90 triangle and a 45, 45, 90 degree triangle, right? But that's for next week when we get into right triangles. Now, we also have an acute triangle, where it's a triangle where all of its angles are acute. Remember, an acute angle is where it's between 0 and 90, so essentially less than 90, all right? So again, we can have an acute scalene triangle, we can have an acute isosceles triangle, and we can also have an acute equilateral triangle, all right? Now, with equilaterals, they're always going to be acute because, again, we already know that their angles are going to be 60 degrees at each of its corner, all right? Now, we can also have an obtuse triangle where one of its angles is, obtuse. And remember, obtuse means it is more than 90 degrees. So we can have an obtuse scalene triangle and we can have an obtuse isosceles triangle, all right? So it's just really handy to know all these different types of triangles. All right, now into the really important part. So we have the triangle sum theorem, right? Which states that the sum of the measures of the angles of a triangle is 180 degrees. So look, angle 1 plus angle 2 plus angle 3 would equal to 180 degrees, and that's a set firm thing. And we're actually going to see how this plays a role in all the ACT and SAT questions that can possibly come out in our deep dive lesson, all right? Now the next thing that we have is the triangle exterior angle theorem, where it states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. And this only plays for triangles, all right? So we look here, we have angle A and angle C. If we add angle B, if we add angle B and angle C together, we can actually find what angle A is. And that is the triangle exterior angle theorem, right? B plus C would equal to A. If you have any questions about this, bring it to your deep dive lesson or send me a message. All right, now, what is a polygon? So poly essentially means many, and gon means angle. So a polygon, is any complete shape having more than two sides and only straight sides. So that means a circle is not a polygon. This would not be a polygon because it's not complete, it's not closed. This would be considered a polygon because it's closed. This is a polygon. This is not a polygon. This is not because it's not closed. So as you can see, a polygon has to be closed. These are not. All right. Now, just a quick thing. So a perimeter, there we go, is the length of the outline of a shape, and it can be found by taking the sum of the side lengths. And we'll actually get into this in week 10, where we go over measurement, area, and volume. All right, so just putting that definition out there right now. Now, angle total essentially is the sum of the angles of a polygon, and we're actually going to see that right now, what that is. So with a polygon, we can find its total interior angle as well as its exterior angle. Now, to find the sum of the interior angles of a polygon, we would use this formula. All right, so A is the total angle, N is the number of sides the polygon has, and we're going to subtract that by 2 and multiply by 180 degrees. So for example, if I have a 5-sided shape, so 5 sides, right? What I'm going to do to find its total interior angle is plug 5 into where N is. So 5 minus 2 times 180. So 3 times 180, which will give me a total interior angle for will give me a total interior angle of 540 degrees. All right, and that's how you would find the sum of the interior angles of a polygon. Now, sometimes they might ask you, what is the interior angle of a specific vertex or corner of a regular polygon? So like, for example, let's take if this is a regular polygon, right? And they want you to find this specific angle. What we would need to do is, again, find a total interior angle and then divide it by the number of sides, right? So in this case, say I want to find the interior angle of this 5-sided the interior angle of a regular pentagon, right? Because a pentagon is 5 sides. So what I would need to do from here is, now I am going to take 540 degrees and divide that by 5, right? Which would then give me, let's see, which would give me 108 degrees. Which means that here is going to be 108 degrees. All right, and we'll actually get more into this with some of your questions in your deep dive lesson. But anyways, here is also a really useful table to have to see how it relates to each other for it's the sum of the interior angles as well as each angle. All right, These are the really common ones, so it's also really handy to know. Okay. Now, we can also find the exterior angle of a polygon, right? So essentially the exterior angle of a polygon is the angle that is formed between any side of the polygon and the line extended from the next side, right? And it's also given that the sum of the interior angles of any polygon is equal to 360. All right, so let's say you have a million-sided polygon, right? And the question is, what is the total exterior angle of a million-sided polygon? Straight away your answer will be 360, because the total exterior angle, right, would be 360 degrees. Now, to find what one of the exterior angle is, so let's say we have a shape. Let's take this one, right? So we have a triangle, and we're going to just project a line past it. So we know that this equilateral triangle, this regular triangle, will have 60 degrees. But we pass that line, we know that this is going to be 120 degrees. And so that means the exterior angle of a regular triangle is 120 degrees. Now we take this pentagon. Again, we're going to extend this line, right? And then we know a straight line has a total angle of 180 degrees, which is why we want to project this line, because we know the interior angle is going to be 180 degrees, which means the exterior would be 180 minus 108, which would equal to 72, which is why the exterior angle of a pentagon is 72 degrees, or a regular pentagon is 72 degrees. All right. If you have any questions about this, bring it to your deep dive lesson. Now, you probably have heard me say this before. What is a regular polygon, right? So think about this. Polygons, they can be equiangular, which means all of its angles are the same, right? Or equilateral, which means all of its sides are the same length, or they can be both. Now, if a polygon is both equiangular, which means all of its angles are the same degrees, right? And it's also equilateral, then it's what we call a regular polygon. So as you can see, this would be a triangle, this would be a regular quadrilateral, a regular pentagon, regular hexagon, heptagon, octagon, nonagon, decagon. Also, a really helpful tip for you to know how many sides it is, if they don't tell you in the question like how many sides the shape is let's say find the exterior angle of a nonagon. You need to know what nona stands for, right? So nona stands for 9. This is how you remember. So essentially a straight line, it's one side. Technically it's not even the shape, right? But a straight line is 180 degrees. Two lines don't make a shape, right? So the smallest you can go for a polygon is triangle. So tri means 3, quad means 4, penta, as you can see, means 5, hex means 6, hepta means 7, octa means 8, nona means 9, and deca means 10. So as long as you remember these shapes and what their prefix stands for, it'd be really, really helpful to know how many sides they have. All right. Now on to the last thing of the day. We have lines of symmetry. So not many questions come up for lines of symmetry, but it does come up. So we do need to know what exactly is a line of symmetry, right? So a line of symmetry essentially is a line that divides a shape into two identical halves, right? So irregular polygons, so remember, regular polygons are the ones which are equiangular and equilateral. So an irregular polygon isn't equilateral and or equiangular, right? So it's not equal to some parts. So irregular polygons, generally, they don't have any lines of symmetry. There are a few exceptions, such as an isosceles triangle, where it has one line of symmetry, and a rectangle, where it has two lines of symmetry. All right. Now, a regular polygon would have n lines of symmetry based on its number of sides. So let's look at this really handy table. All right. So we look triangles, a scalene, because all the sides are different, it will not have any lines of symmetry. And isosceles, down, the middle, so one line of symmetry. And then an equiangular, because it's a regular triangle, it will have 3 lines of symmetry. All right, so now quadrilaterals. A rectangle, 2 lines of symmetry. Trapezoid, no line of symmetry. A rhombus, 2 lines of symmetry. Parallelogram, no lines of symmetry. A square, so essentially a square is a regular quadrilateral, which is why it has 4 lines of symmetry. And a kite has only 1 line of symmetry. Now let's look at here. Here are all of our regular polygons, the other ones. So look, regular pentagon, regular hexagon, regular heptagon, regular octagon, regular nonagon, and regular decagon. This has 5, 6, 7, 8, 9, 10 lines of symmetry, and see how the number of sides coincides with the number of lines of symmetry, right? So just a really good thing to remember is that for regular polygons, it has the same number of lines of symmetry as its number of sides. And that's essentially it. Alright, so if you have any questions about today's pre-lesson video on polygons, as usual, send me a message, email, or bring it to your deep dive lesson. Alright, thanks for tuning in. Have a good rest of your day.